Thanks for sticking it out. It's getting late in the afternoon. And a lot of this material has been covered several times in the conference, but I'll try to reiterate some of the things and give you some personal experience relative to deploying these types of technologies and what we're looking forward to relative to deploying the narrowband IoT and CATM technologies. And those are two that I'll primarily focus on relative to Release 13. You guys are very familiar with some of the short-range technologies, and the thing that I'd like to do here today in the next 10 minutes is really try to perhaps make you start thinking about how these are going to relate together, particularly from the point of view of applications and how they're deployed. You know, particularly some of the longer range technologies and how those will overlap with some of the new opportunities within narrowband IoT particularly, and some of the use cases that these companies and technologies have been touting for the last several years, and now what's going to happen over the next few years. And one of the things, since a lot of the, what's CATM and narrowband IoT use cases and what are the technologies and things like that in Release 13 or Release 14, I also would like for you to sort of think of what happens in 5G relative to the platform. So what is it in the platform that's really going to enable some amazing things that may not be in those releases and enable some opportunities within that? So really, there's three technologies from a narrowband standpoint that we should be thinking about, but one of them I don't know that we need to worry about that much because there's a lot of overlap with it. The first one, of course, is CATM, the machine type communication standard. The second one is the narrowband IoT that folks have been talking about. And the third one is actually the extended coverage GSM that I'm not going to talk about at all. And the reason is that it truly is an extension from a GSM technology. But what's interesting about some of the LTE technology is that it has, particularly in narrowband IoT, is that it has the opportunity to work within the GSM bands. And so since there's really two answers to that problem of the GSM spectrum and the refarming of it, I'm going to ignore the third of these three since I only have 10 minutes. So what was the original mission of the 3GPP? And I do have a background in standards and things like that. But I was, for instance, the TR50 chairman of the first M2M communications for the TIA, and I was also the convener of the GSC for the United Nations for M2M communications. So really simple, cheap devices, low energy consumption, delay tolerant, and massive numbers. And by delay tolerant, it really means the opportunity to be able to have latency issues and also be able to go to sleep. Forward. Okay, within that mission then, you can see that really on the right-hand side, some of the critical machine type communications, not part of the CATM and narrowband IoT, really more in the CAT1 with very, very low latency, 1 millisecond type latency, which is the type of latency that you're looking for when you do switch presses and be able to get a response. That is not the application domain for these two technologies. But really, some of the enhancements, for instance, within EMTC, the CATM standard, you got things like support for positioning. So there is, in fact, a synchronization protocol built in to allow the device to be able to, when it does its transmission, to be able to listen to that transmission from multiple towers and do triangulation to be able to do some types of positioning. It's not really going to be that much be able to be utilized within Release 13, but in Release 14, it's expected that you'll be able to do some positioning type technologies with these two, both the EMTC and the narrowband IoT. Support for multicast transmissions, which is the capability to be able to transmit and have multiple receivers of that information. What's interesting about that is the opportunity, and this is what I mean by a platform in 5G, and that is all of a sudden you also have the capability, if you read into it, mesh technology. And so if you take if you take the idea of being able to do off-band and you take the idea of mesh technology and you merge those two together, you have the opportunity to be able to have off-band mesh technology that goes through a gateway to be able to transmit up using narrowband technology. And that's going to be very interesting, particularly for very, very low power type transmissions. You also have broadcast capability, and so you can broadcast down to many devices at a time. You have mobility capability for interfrequency, and you have, to some extent, some higher data rates in the CATM, and eventually you'll have support for VoLTE technologies and voice. Narrowband IoT, many of the same enhancements in narrowband IoT of the for the EM standard, but latency is going to be a huge issue. And what this has to do with DRX, and the DRX protocol really allows you to be able to go to sleep. And what it is it allows the system not to freak out if you don't do the regular paging to say, I'm here, I'm here, I'm here, I'm here. And so if you shut that down, the node does not necessarily need to worry about trying to look for you. You can wake up later. Well, in release 12, it increased it to about 2.4 seconds, and in release 13, it's increased that to about 7.5 seconds. And so if you think about it when you do your power management, being able to sleep for 7 seconds and then wake up to be able to maintain your registration on the network and then go back to sleep again, that's a very powerful thing from a battery life standpoint. And that's why we're able to get the kind of ideas of getting 10-year types of batteries with a 10-year type of application on a very small battery. So we also talked about multicast is also in the NBIOT. Power consumption is one area that both from a transmission standpoint and a receive standpoint, and falling asleep is very important. Paging enhancements, the capability to be able to go online and then not do those pagings like I was talking about relative to the power consumption. And then things like new power classes, which are the ability to be able to transmit at a different power. And one of the interesting things about it is that you really, in narrowband IoT, have an opportunity to be able to get an increase in about 20 dB. And if you do all the math and everything else, you find out that what's 20 dB mean? Well, in free space, 20 dB is about 7 times the area coverage. So that's what you can think of. If you do all the logarithms and everything else, it comes out free space 7 times the area. Now, unfortunately, well, if in your agriculture application and you're on a pool table, that's not a problem. But so what's reality? Well, reality, worst case, is a building, right? Sub-basement, trying to get data out of a vending machine down in a sub-basement, or from an automobile that's located in a sub-garage. Well, what a 20 dB gain really is getting outside of a wall, a reinforced concrete wall in a building. And that's something, because you're talking about a relatively low-powered device to be able to do that. And then we talked a little about enhanced DRX for narrowband IoT. That's the idea of being able to get this power savings capability by going to sleep. The other really interesting thing about the narrowband IoT enhancements are the ability for it to be able to stand alone in the GSM space, which I mentioned briefly, but you can also go in the guard band. So the opportunity for to be able to have this 200 kilohertz channel within the guard band between LTE channels means that from an efficiency standpoint, that's going to be within a operator network. That's going to be very valuable. And then and so it also comes at basically no cost, right? Because it's not chewing up very, very valuable bandwidth. And then the last one is the ability to be able to go in band with LTE and be able to be compatible with it. Just to give you an idea, from a transmission standpoint, it's in the CATM technologies. It's originally in the specification is about 1 megabits per second up, 1 megabits per second down. Didn't quite make that in most of the trials. There's a good article in the Proceedings of Communications that just came out recently in the last couple of weeks. And it talks a lot about, okay, what was originally promised and what's really being delivered, and some of the nuances there. What you find in the narrowband IoT relative to the transmission requirements is it's about 60 kilobits per second on the up channel and about 20 to 40 kilobits per second on the down channel. I'll save this eye chart for you, but I have a couple other notes that we might be able to talk about, and then I can take some questions if you'd like. But just to give you an idea, when we were talking about transmission capabilities, in the 20 dB that you get relative to the sensitivity of the received part of the radio for free space transmission will enable some technology for fixed to be able to get that. But if you're in a mobile application, you probably won't receive that kind of 7 times coverage like capability. The other real interesting thing about both of these technologies is that within the 3GPP, they've wrote the specification in such a way that it's really EPC light. So there's 2 things we talk about relative to how you design these radios, and the radio on the tower and the radio at the device. And the radio in the tower is really relatively complex when you talk about LTE. Well, when you talk about machine type transmissions, can we make a radio which just has just the components that it needs? And if you can do that, you can stick it in a bread box, and you can have it with off-channel, and perhaps even in some of the GSM channels, which are 900 and 1800 megahertz, or even other frequencies, which are not licensed frequencies, all of a sudden think about what might be possible relative to that, because now you can have these sort of bread box things, a lot like LoRa, frankly, okay, up on the towers that have the ability, or within your factory, or within your building, and things like this. So all of a sudden, at the core, you have a very, very simple core to be able to have a very low-cost device, not all the complexity of a true cell tower in LTE. Now then talk about the actual device itself. On the device itself, the processor that most people are talking about right now is the Qualcomm 9206. And the 9207 is really what's being used in the CAT1 technology. The 9206 is coming out with silicon relatively soon. They're probably doing trials right now. We can talk to the Qualcomm guy to find out what's really happening. But they're talking about releasing of that in the 2018 timeframe. And what's interesting about that particular silicon, it's the same chip that they're going to use for both narrowband IoT and CATM. Okay, so that's interesting because now we'll get volumes. Now it's a little bit uninteresting because now you've got the same complexity for narrowband IoT as you do for CAT-M. And so the complexity of the silicon is related to the cost. And so the arguments of this sort of $5 to $10 device relative to narrowband IoT is possible in the future, but probably in the near future, you're talking about getting something out a little earlier, which is a CAT-M that really plays like a NBIOT device, and it's probably going to be slightly reduced a cost, but not that much reduced. Now, another very interesting thing about this is that the narrowband IoT has the ability to be able to, and a 9206 processor, because it's a half duplex radio, which means it either transmits or it receives, but it doesn't do both at the same time. It's half duplex. What happens is that it has the ability to be able to do other things. And so that processor is not running both programs basically at the same time. That's a simplification. But what you can do then is have the ability to do one thing more sophisticated. And that one thing is really software-defined radio. And so the opportunity that I see within that 9206 processor is the opportunity to be able to do the frequency synthesized within the radio, which means that you're going to be able to have a device which has the ability to reprogram itself to be able to do lots of different channels, which it wasn't originally designed for, which means you probably will be able to design that to be able to do things within the spectrums which are unlicensed. So with that, I have 3 seconds left, and I thank you very much.